Hello science enthusiasts. Welcome back to the Viron lab. Today, we're exploring 4 innovative science exhibition models you can build yourself. Projects that spark creativity and could even help make the world a better place. From natural health solutions to green technology, we've got a lineup to ignite your curiosity. This video will be mostly in English, with a dash of Hinglish, because science is universal, but connecting with you is what matters most. Whether you say experiment or prayog, you're in the right place. For each model, I'll guide you step by step, so you can follow along at home or in your school lab. We'll break down the core scientific concepts behind each project, so you understand not just how, but why it works. So grab your lab coat, or just your curiosity, and let's get started. Our first project blends traditional wisdom with modern science. Neem syrup. Neem, or Azadirachta indica, is called the village pharmacy in Ayurveda. Its leaves are rich in antibacterial, antifungal and anti-inflammatory compounds. Let's make a simple neem extract at home. Wash and dry fresh neem leaves, then add 50 grams to 500 milliliters of water in a pot. Boil, then simmer for 15-20 minutes until the water turns deep green. Heat releases powerful phytochemicals like nimbin and azadirachtin. Cool, strain and pour the liquid into a clean glass bottle. Store in the fridge for up to a week. Take a teaspoon daily to help purify blood, boost immunity, and support skin and digestion. Neem water can also be used as a skin toner or hair rinse for acne and dandruff. Neem is potent. Use in moderation and consult a doctor if you have health concerns. Science is about being responsible and safe. This project connects biology, chemistry, and health science. Perfect for exhibitions or home experiments. Science is all around us, even in our backyard trees. Try it out and see the benefits for yourself. You'll be amazed at what a simple leaf can do. Every kitchen can be a laboratory. Keep experimenting and learning. Next up, let's tackle plastic pollution with homemade biodegradable packaging. We'll use cornstarch, water, vegetable glycerin, and vinegar. Simple kitchen ingredients. Measure 1 tablespoon cornstarch, 4 tablespoons water, 1 teaspoon glycerin, 1 teaspoon vinegar. Mix all ingredients in a saucepan until smooth. Heat gently, stirring constantly until it thickens into a clear, gooey gel. This is gelatinization, where starch molecules absorb water and form a new structure. Pour the hot gel onto a lined tray and spread it thin. Let it dry for 1-2 days. As water evaporates, you'll get a flexible, plastic-like sheet. This bioplastic isn't waterproof, but that's the point. It breaks down naturally. When you're done, compost it. Microbes will break it down, returning nutrients to the earth. This project is a hands-on way to learn about polymers, chemical reactions, and sustainability. Compare natural polymers like starch to synthetic ones like polyethylene. Discuss the environmental impact of single-use plastics and the promise of bioplastics. Scientists are developing even more advanced bioplastics from algae and food waste. Your homemade version is a window into the future of material science. It's a powerful lesson in sustainability. Small changes can make a big impact. Use this project to spark conversations about the circular economy and eco-friendly innovation. Perfect for science fairs or classroom demos. Show how chemistry can solve real-world problems. Encourage others to experiment with different ingredients and methods. Science is about creativity and problem-solving. This project is simple, impactful, and fun. Share your results and ideas for improvement. Connect this experiment to broader environmental issues. Inspire others to think green and act sustainably. Every small step counts in protecting our planet. Let's innovate for a cleaner future. Try making bioplastic at home and see what you can create. Discuss the science behind the process with friends and classmates. Explore the possibilities of biodegradable materials. Science empowers us to make better choices. Keep experimenting and learning. The future is in your hands, literally. Let's move on to our next exciting project. Ready for some solar-powered innovation? Now, let's dive into renewable energy and robotics with an automatic solar tracker. Solar panels work best when facing the sun, but the sun moves. So let's build a tracker that follows it. You'll need a small solar panel, 2 LDRs, light sensors, a servo motor, an Arduino Uno, resistors, jumper wires, and a simple frame. Place the LDRs on either side of the panel, separated by a divider. They act as the tracker's eyes. When one LDR gets more light, its resistance drops, signaling the Arduino to turn the panel toward the sun using the servo. The Arduino reads both LDRs, compares values, and moves the servo until both sensors get equal light, keeping the panel perfectly aligned. Build the circuit, connect LDRs and resistors to analog pins, servo to a digital pin. Mount everything on a rotating platform. Upload a simple code to the Arduino to read sensor values and control the servo. Test it outside or with a flashlight. The panel should follow the light source. This project combines physics, electronics, and coding. A true STEM challenge. Solar trackers can boost energy output by up to 40% compared to fixed panels. Even small-scale trackers make a big difference for off-grid power. This is hands-on learning about sensors, automation, and renewable energy. Perfect for science exhibitions or robotics clubs. Show how technology can maximize clean energy. Discuss the real-world impact of solar tracking in large solar farms. Encourage creativity in building the frame. Use cardboard, plastic, or 3D printed parts. Explain the feedback loop sensors detect. Arduino decides. Servo acts. This is the heart of automation and smart technology. Inspire others to explore robotics and green tech. Science is about building solutions for a better future. Share your tracker and code with classmates or online. Experiment with improvements. Add more sensors or axes of movement. Connect this project to broader topics like climate change and sustainable energy. Every innovation counts in the transition to renewables. Let's keep pushing the boundaries of what's possible. This project is a step into the future of energy. You're not just building a gadget, you're learning to harness the sun. Keep experimenting and sharing your discoveries. Science is about curiosity, creativity, and impact. Let's move to our final project, something practical for everyday life. Ready to repel some mosquitoes naturally? Let's get started. Science is everywhere, let's use it. On to the last experiment. Our final project is a herbal mosquito repellent, natural, effective, and easy to make. We'll use lemongrass, citronella oil, mint, menthol, and neem as a diractin, all proven to repel mosquitoes. Gather fresh lemongrass, mint, and neem leaves. Wash and coarsely chop them. Place the herbs in a clean glass jar, cover with witch hazel or rubbing alcohol, and seal tightly. Let the jar sit in a cool, dark place for 1-2 weeks, shaking daily. This extracts the essential oils. Strain the liquid, squeezing out every drop, and dilute it one with distilled water in a spray bottle. Your natural mosquito repellent is ready. Makharon ko baganeka natural tarika. Spray on exposed skin. Reapply every hour or two, especially if sweating. The strong scents mask your natural odor, confusing mosquitoes and keeping them away. This project is a great way to learn about plant chemistry and insect behavior. Discuss how essential oils act as natural pesticides and how insects use smell to find us. Natural repellents are safer for many people, but may need more frequent application. Perfect for science fairs or home use. Practical, safe, and eco-friendly. Encourage others to try different herbs or extraction methods. Science is about experimenting and finding what works best. Share your results and tips with friends and family. Connect this project to broader topics like biochemistry and entomology. Explore the science behind natural remedies and pest control. Every experiment is a chance to learn and improve. Science can make daily life better, one spray at a time. Keep testing and refining your formula. Discuss the effectiveness and safety of natural versus chemical repellents. Inspire others to use science for practical solutions. This project is hands-on, relevant, and fun. Let's keep exploring the power of plants. Science is everywhere. Use it to solve real problems. Share your herbal repellent with your community. Keep learning about the chemistry of everyday life. Science empowers us to make healthier choices. Try this project and see the results for yourself. Let's wrap up our science journey. Stay curious and keep experimenting. On to our conclusion. And there you have it. 4 inspiring science projects you can create yourself. From neem syrup to bioplastics, solar trackers to herbal repellents, we've explored chemistry, biology, physics, and engineering. I hope you're inspired to try these projects, experiment, innovate, and share your results. Science is about curiosity, creativity, and community. So share your experiences in the comments below. Let's build a community of creators and thinkers together. If you enjoyed this, hit subscribe and ring the bell for more hands-on science. Science is for everyone, no matter the language. Until next time, stay curious.